Right now, 4.24 light-years away, there is a star, the closest star to our sun, the nearest light in the dark. For decades we dreamed about it. We named planets around it. We imagined oceans, atmospheres, maybe even something looking back at us through the red haze. We were wrong. Proxima Centauri is not a beacon of hope. It is a trap. From Earth, Proxima is invisible to the naked eye. It is a red dwarf, a dim, smoldering ember compared to our sun, producing only a fraction of the light and heat we receive here. If you stood on its nearest planet and looked up at noon, the sky would glow a deep, bruised red. The star would hang enormous and dim above the horizon, like an infected eye staring down from a rust-colored sky. Nothing like the clean blue, you know. Nothing like home. But do not let the dimness fool you. Proxima Centauri is violent in a way our sun has never been. Red dwarfs are the most common stars in the galaxy. They look weak, forgettable, but they are wound too tight. Their magnetic fields are tangled, unstable, perpetually on the edge of collapse, and when they release that stored energy, they do not release it quietly. Proxima fires super flares, explosions of radiation so intense they make everything our own sun has ever produced look like a flickering candle. In 2016, astronomers measured a flare from Proxima that was 10 times more energetic than the most powerful solar flare ever recorded in Earth's history. Think carefully about what that means. The strongest flare our sun ever threw at us caused global radio blackouts, disrupted satellites, and knocked out power grids across continents. A Proxima-scale event would not disrupt infrastructure. It would strip the ozone layer bare. It would sterilize the surface in minutes. The ultraviolet radiation alone would be lethal to every living thing exposed to open sky. And these flares are not rare. Proxima erupts multiple times per day, every single day, without pause, without mercy. It is a star in a permanent state of rage. Now, here's the part that should stop you cold. Proxima b, the planet sitting in the so-called habitable zone, the planet that receives just enough heat to theoretically hold liquid water, orbits impossibly close to the star. One full year there lasts just 11 Earth days, 11 days to complete one full orbit around a star that is constantly trying to kill it. At that distance, the radiation bombardment is relentless and total. Scientists calculate that Proxima b receives 250 times more X-ray radiation than Earth receives from our sun. Any atmosphere it might have painstakingly built up over billions of years would be sandblasted away, stripped particle by particle into the void of space. And if by some miracle it kept an atmosphere, the planet would be tidally locked. One face permanently baked under dim red light, the other frozen in absolute airless darkness. No sunrise, no sunset, no seasons. Just two eternal hemispheres that will never trade places, never breathe, never change. At the boundary where they meet, a permanent wall of wind, a screaming jet stream circling the planet forever, a scar written in atmosphere. The light side cooks, the dark side freezes solid, and the narrow strip between them, the perpetual twilight ring, is the only place anything could theoretically survive. A thin ribbon of marginally livable conditions wrapped around an irradiated atmosphereless rock. That is the best-case scenario for Proxima b. That is what we were calling exciting, but Proxima b is not even the strangest world in the system. In 2020, astronomers confirmed a second planet, Proxima d. It orbits even closer to the star than b, completing one full year in just 5 days. It skims so close to the stellar surface that every single flare hits it point blank. No distance to soften the blow, no orbital buffer to absorb anything. If Proxima b is a hostile world, Proxima d is something beyond hostility. It is a rock sitting inside a microwave that never turns off, and this entire system is not alone. Proxima gravitationally orbits two other stars, Alpha Centauri A and B. Together, the three form a triple star system. From the surface of Proxima B, on a clear night, if clear nights existed there, you would see two brilliant points of light hanging in the sky. Alpha Centauri A and B, close enough to each other to almost appear as one, blazing brighter than anything else in the night sky. They would cast faint shadows on the ground below, two distant suns gently lighting the darkness of a world that its own star is actively trying to destroy. We know all of this. We know about the flares, the radiation, the tidal locking, the merciless proximity. We have the data, the measurements, the models. We know exactly what Proxima is. And we still dream. A project called Breakthrough Starshot has proposed launching tiny spacecraft, laser-propelled probes no larger than a postage stamp, toward the Alpha Centauri system at 20% the speed of light. They would reach Proxima in roughly 20 years. They would photograph the planets, sample the atmosphere, and transmit back the first real images of another world orbiting another star. Not in science fiction. In our lifetime, but before the probes, we sent something else. In 2008, a transmission was beamed from a radio telescope in Ukraine directly toward Proxima Centauri. Digital data, photographs, music, a message in a bottle thrown into the dark. That transmission will arrive at Proxima in 2036. If anything is listening out there, it has already received what we sent. We've already told our nearest neighbor exactly where we are, exactly what we sound like, exactly what we look like. We introduced ourselves to a killer. Proxima Centauri is not a promise. It is a warning written in starlight. It tells us that closeness in space means nothing, that the universe does not organize itself around our comfort or our hope. Our nearest stellar neighbor is a rage engine, a star that erupts every day, that locks its planets in half-light, that sandblasts atmospheres into nothing, that offers a thin twilight ring as the best it can do for life. We point our telescopes at it and call it the most exciting nearby star system. But exciting and survivable are not the same thing. They have never been the same thing. The universe is full of lights. Not all of them are invitations.